This is the quickest setup I've ever had, because normally you go to conferences, you have to plug in all your adapters and everything, and it doesn't work. But here, it's like, this gentleman out there helped me just plug right in. So that's awesome. Yeah, let me also make sure my time. OK, so I realize, OK, cool. Let me kind of also make sure it works. Yeah, OK. How do I go back? OK, cool. OK, I think I should start now. Savannah, you're all good, right? With Savannah scanning your badges in order for you to qualify for our $500 gift card. So yeah, that's a very good thing. And if you visit our booth too, you also get another chance to win another card too. So potentially you can win more than just one. OK, so first of all, thank you so much for coming to my talk. I know it's kind of late in the day. It's starting to be late in the day on the second day of conference. So normally, not as many folks, and there are other tracks. So for you to be here, I really want to thank you for spending your time here. I hope it is going to be useful for what you're looking for. If not, just learn something and like that. So, OK, so my topic is about event streaming and essentially to help to supercharge your business. And that's primarily the goal of using like an event streaming type of approach to solving your business problem. Doesn't solve all problems, but certainly too, for the right kind of problems you're trying to solve is meant to be very, very fast. Scalability, resiliency, responsiveness, all of these good things. OK, so, and my name, before I start too, if you like to follow along right here, this is the bit.ly link to my slide deck, and if you want to follow along the QR code, even if you miss, don't worry about it, because I'm going to be sharing the link with the organizer as well. So, all right, I'm just going to go ahead because I don't have as much time. So who am I? Just a quick intro. I'm a senior developer advocate at DataStax, which is, as you know, we are sponsoring the event here. We are a leading data management company that specializes in database as a service on the cloud, no SQL, now like big data, and then adding in streaming and on the cloud native platform. It's truly cloud native too. And I was with the Java and WebSphere open source team, advocacy team at IBM for 3.5 years previously. And then I actually also was in development myself, like doing all the work from development all the way, doing some architecting, production support, all these things for about over 20 years in Java area. So I'm also a Java champion, and I'm based in Chicago. I'm also president of the Chicago Java Users Group. So I'm heavily involved too with the community. And I do believe in having a strong technical community is always good too. Like you find that you are always, you need to be constantly learning new things. It's a good way to kind of stay in touch and then be with the community. So I encourage you to do that. And then these are the various ways you can get a hold of me. And I will be sharing with you again towards the end of my slide deck with how you can get a hold of me. OK. And this is just another slide that describes what I'm doing. So I already talked about it. Primarily, I'm doing streaming and advocating for that for DataStax. And my interest primarily is also into distributed systems. It's kind of, I'm passionate about doing that. So, OK. Now, then let me quickly give you a agenda of what I'm going to be talking about. I wanted to give a bit of an introduction to event streaming, event messaging, all of these things about events. It seems to be the latest buzzword of these days, right? Events is everywhere you hear. Just want to clarify a couple kind of understanding of the terminology so we get a good understanding, or at least on the same page here, and also explaining some of the semantics that's being used by event-driven type of processing space. And then I also wanted to talk about like, how can event streaming augment your business, like really supercharge your business. And then I will introduce you to Apache Pulsar. That's what DataStax, where we have Astra streaming, which is like running on top of the Astra DB cloud platform, but it's powered by Pulsar. And so I wanted to introduce you about Pulsar. It's much deeper than what I can explain everything today, but I want to give you an introduction. And also its dependency on Zookeeper, and Bookkeeper is very open source, kind of in nature. And I want to highlight a couple features of Pulsar too, and also like why. And it's essentially extending what Apache Kafka can do today. And may I kind of see a show of hands who have heard of Apache Pulsar Just curious. Okay, yeah, there are a few of you. That's good. And then how many of you are already working with event-driven type of systems, maybe like asynchronous and all these? Okay, very, very cool. So at least you have, some of you have. But I have to kind of assume a bit of an introduction. So let me kind of talk about events. Basically, too, in the computing world, events is kind of very different, as some of you are aware. It's not the same as how we traditionally learn how to program, right? When we program, we tend to be, when we first learn, it's always having a request, some command comes, and then essentially, too, you have to wait for the response to come back. And so I actually first look up to and look at event. Why do we call it event? And I want to look up into the dictionary to get an understanding of event. So that's from Merriam-Webster.com. It's about something that just happens. It's an occurrence. So that's the fundamental understanding. We know it's an event that can trigger something else to happen. Here, too, I wanted to bring it a bit more into the nerdy space about the theory of relativity. It explains event is the fundamental entity of observed physical reality represented by a point designated by 3 coordinates of place and then 1 of time in the space-time continuum postulated by the theory of relativity. So think of it as more like events. We're dealing with events by itself is a point in time. In a mathematical model, it would be x, y, z coordinate. And then it travels through time. So we have to kind of, in computing sense, we have to track the changes. And of course, it becomes more complicated if we're dealing with streams of data, which is not just one event. There are many events that are happening. So that's the space we're in to trying to solve the problem. And how does it, kind of get into doing business, solving problem? That's what we're trying to figure out here. So a bit more too about event streaming and processing. So basically, the practice of taking action on a series of data points that originate from a system that continuously creates data is what event streaming and processing is all about. So, and then event, again, is referring to a point in the system. So kind of think of it like a system, you have the point, and the stream is like ongoing delivery of those events. And that's the challenges we face now when we have to deal with real-time type of processing, because you want to react to it right away and do something about it. It should trigger some action that produce some desirable business outcome. That's the streaming side we're dealing with. So a series of events can also then be referred to as streaming data or data streams. Okay, and then complex event processing. So complex event processing is basically a set of techniques and capturing all the data and analyzing all of these streams of data as they arrive. And what's the purpose is to identify opportunities or maybe threats, right? So that's one good use case of using events is to do fraud detection, for example. And then, we want to respond, is the complex event processing is to look at the data, analyze it, and produce some kind of action on it, right? Responding to the events, some trends, or you are shopping, you want to produce some recommendation data, for example, things like that. Okay. And now a bit of also about messaging too. There are differences between event-driven messaging and then message-driven messaging. Event-driven is really about, primarily is kind of represented by the publish, subscribe type of messaging, kind of a paradigm, in which you have a sender. Any kind of messaging is always sender and receiver. Event-driven is dealing with one sender, but there can be many receiver, depending on how many subscribing to this message. So it's an event-driven. And then message-driven is dealing with sender and one receiver, and point-to-point type of communication, and then they both have to know each other. Know meaning that, in computing sense, you have to know the address of where the messages is going to, whereas going back to event-driven is about pub/sub, is really the publisher, whoever is publishing or producing the messages, you don't need to know where the messages is going to go to because you're relying on a broker, like a post office, right? A post office agent that helps you to deliver the messages accordingly. Okay, so you might be wondering, well, I'm in an API conference. What does this have to do with it, right? So that's the kind of a bit of a change of paradigm I wanted to kind of bring up to. It's something I decided to kind of explain kind of on the fly. Because for API, I think our understanding is always about, okay, we're defining an interface that you're talking, how do you talk to the system? you kind of, almost like a function, maybe you kind of tell it, these are the data I want to pass into the function, and that's the application program interface, and it does something and returns you some kind of value. Now, in messaging system, it's kind of different. You don't do it like that. Your data is sort of a bit more abstract, I should put it like that. So API-wise, we're leveraging on this publish, subscribe type of mechanism to deliver your data. So your data will have kind of like different way of being expressed in this interface, essentially. I know it's a bit abstract, so bear with me a little bit, but I wanted to kind of point that out to you. It's still an API, but it's not like a traditional kind of API. Okay, and let me kind of move on a little bit. Now I'm talking about event-driven, event approach, right, all of these things. And so you may also be asking, events processing has become the thing, but what was being used, right, previously? And that's actually more with batch processing type of systems, as maybe some of you are dealing with batch processing. Essentially, you are gathering all the data and then process the data accordingly. For example, like system of record in a human resources system in your company. You don't want to necessarily have to, every change in your employee, if I go in, right, as an employee, I update my information, you don't want the system to immediately update your data right away because it's not very urgent. That you can wait and you batch it up. So then you don't take up like valuable processing time during the middle of your day. When you need to be answering questions from your customers, all those are more urgent, right? They need more of an event-driven type of approach. So that's something I want to also point out. Let me make sure the time. Okay, now then let me get into a bit more event messaging. Semantics, right? So it's essentially like the mechanism of making these messages to kind of communicate with one another. I already hinted too, is about Pulsar, this time a mechanism. So Pulsar in this way of doing things is we rely on the broker. The broker, think of it, not even computing, is kind of like like a post office, postmaster that I talked to you about. And if I'm sending the messages, I don't need to know who the messages would be going to. I just send it to the broker. The broker will take care of things for me. And in order for me to tell the broker what this message is about, I use a topic, and that's what it's called. Sometimes some systems calls it a channel, so you essentially categorize your messages, a channel or some kind of router thing. So then the broker will know how to route the messages. So that's how the Pulsar system works. And then on the receiving side, it's more like you, as a subscriber, you are interested in some messages, then you subscribe to that topic or subscribe to on the channel. Then you'll be receiving messages when the messages happen. So it's a very asynchronous kind of thing. You keep your subscription. You don't necessarily get the messages right away, or you have to wait until the producer produces the messages, then it comes. Now, as you can see too, the benefits of such is that it handles messages in really like bulk. For example, like IoT type of applications. You can have actually a field of a lot of devices installed in the field collecting temperature information. These devices are sending messages out to your server somewhere in the cloud, right? And so you can have hundreds or thousands of temperature gauge in the field, devices collecting data. They can constantly be sending data. So you'll be constantly streaming all your data to your server like that. So that's kind of usually IoT kind of use cases would be making use of a Pulsar type of broker to help you to transfer all of the messages over to your server like that. And it can be done very quickly. It can be like 1 million messages within a minute, something like that too. So that's the kind of the pluses of using a Pulsar. And that's what too is that the Pulsar that I'm going to talk to you about is using a publish subscribe kind of pattern. Okay, another mechanism of doing kind of message transmission will be a message queue. So the queue is slightly different. It's also helped with asynchronous service-to-service communication, right? It's used primarily also in serverless and microservices architecture, but it's more about point-to-point. Again, it's about my sender knowing where the message is going to. And so it decouples. So that's the key in kind of event-driven type of system is you decouple the client and the server, so you let some broker in between to worry about delivering the messages for you. So that's message queuing. Again, message queuing is one-to-one, but the Pulsar is one-to-many type of relationship. Okay, let me kind of really hurry now, I think. Okay, so event streaming, let me get into that. So what is driving this change, right? And why is it I named this title of my talk like Supercharge Your Business? Again, what type of problems can it solve, right, in the real world? So basically, what pops up with this kind of event streaming mechanism, it helps with, you want to basically have processing being able to be done in real time, quickly. There's no need to batch up all of your data. As I mentioned about if you're handling a customer, changing their flight information or whatever, changing their seat right away, you want that to be immediately be ready to, to be processed and get printed on their boarding pass right away, that type of stuff. So it's really using event-driven is really the real-time aspect that you can enhance your customers' experience. They get the result right away. They don't need to wait. And then another use cases could be is building data pipelines. So look at all of your systems, they are just data. I think some of you are working with systems that are financial data, and a large part of it could be trading, and you can be having buyer, seller at any time making bids and all of these things. You actually essentially can build out data pipelines that are, have very fast data streaming into your system, market data, all of these things through data pipelines. And also artificial intelligence, machine learning ops kind of systems that you need to constantly be modifying your model to. It can be done immediately, and then it can be, essentially you don't need to wait. It's kind of the response time should be really fast like that. So it's building data pipelines for these applications. And another thing is really dealing with scalability too. As I mentioned, in an IoT, for example, a hypothetical situation, you can have many devices in a field gathering data. You can add devices to it. It shouldn't be a big problem, especially if you're running, for example, like Pulsar, our extra streaming in the cloud. You can immediately add more brokers cluster to your whole ecosystem, and it should Pulsar also, too, I'm already telling you ahead of time, Pulsar has the capability of knowing how to balance all of my nodes, my topics, running on which server, all of these things, and you can scale up and down really quickly. So that's kind of like the advantages of using an event-driven, event streaming type of approach. Now, again, summarizing, basically, too, using event streaming, you can watch for the events with the system or the application. You subscribe to the topics to see certain types, right? And you make decisions on the data in real time and not after the event. And essentially, you allow your system to ingest high frequency of messages with very low latency. And that's the goal. Okay, so now let me really quickly then introduce Apache Pulsar. What is Pulsar, right? So that's what we're using at DataStax to power our Astra streaming capability. Pulsar itself is an open source project created by Yahoo. They contributed to Apache Software Foundation. So it's all community driven now. Their members, for example, DataStax, we have committers, project committers and PMCs. They are program chair into helping to make strategy and decision in that too. So that became a top-level project in 2018. So as you can see, it's gaining popularity. And you may also be asking, maybe some of you are already using some form of messaging systems like Kafka. Kafka also can do the same thing, except that Kafka was designed and developed before the cloud-native time. So it did not take into account all of the necessary things that you need in a cloud environment. For example, your clusters. How do you deal with multiple data centers scattered throughout the world, that type of stuff. So Pulsar has this concept of geo-replication, multi-tenancy, all of these things that kind of easily help you to organize all of your data and the data centers very easily to manage it as well. So again, the second point is cloud-native design. I like to call it Pulsar was born with the cloud native in its DNA, right? So it kind of already knows how to do a lot of things. So then it frees the developers from worrying about dealing with how do I manage all these clusters, they're growing and rebalancing all of these things. Everything is already very flexibly handled by Pulsar. Okay, and also another thing about Pulsar is that it guarantees your message delivery. Anytime with kind of asynchronous kind of systems messaging, you always have to worry about this aspect because messages get sent at any time, and how do you track it, right? So Pulsar already has this mechanism of making sure it's the broker's responsibility to make sure that messages gets delivered to the intended kind of recipient as well, whoever subscribes to it. So it has that built-in mechanism. And then there's also a what's called like a lightweight serverless functions framework in which data flowing through, you want to also modify at some times, right? You may not want the data to come out on the other end as is. You need some kind of filtering, some kind of functions to kind of do any kind of transformation on your data. Pulsar also has a functions framework. It's very easily, you can done it and develop in Java or Go or Python, for example. And then there's also a tiered storage offload. So basically, too, think of all of the messages flowing through your system. There are tons of them, too. And there's got to have mechanism of how do you deal with all of these big, all of these log, so to speak, like they are distributed log messaging. So Pulsar also has this mechanism of knowing when to archive them if the messages becomes cold. If you've done a certain amount of data, you can actually make sure that it gets offload to cold storage, that type of stuff. So these are just highlight of some of the pluses of using Pulsar. Okay, again, summarizing is that Apache Pulsar is a unified distributed messaging and streaming platform. It's open source, developed at Yahoo, now is a community project, open source at Apache. Cloud native, supports running on Kubernetes and multi-cloud and hybrid cloud. And of course, we also have our DataStax Astro streaming. It's powered by Pulsar, very powerful too. Okay, so who else is using Pulsar? As you can see over here, just a handful of companies here, and Yahoo being the main one, they're still using it, and Verizon, the telecom, and some of the companies in Asia, in China as well. Okay, so Pulsar is very different. Let me kind of really quickly kind of show it to you. As such, right, it's a pub-sub type of mechanism. So you need to have client applications that can be written, again, in Java or Go or Python, some of these, .NET as well. So if some of you are doing .NET kind of framework, it also supports .NET client. So you can do it producer, consumer written in those languages. Also not very complicated too, I have to say. Anyway, so there's also broker, which is essentially the stateless process. It's the postmasters that deals with helping you to route all of your messages. And then Pulsar relies on an Apache project called Bookkeeper. The Bookkeeper is the specialized kind of service that helps you to persist all of the messages that throws through the system. So it makes it, think of it this way, right? Pulsar is very efficient. Pulsar worries only about the messages coming through working with the broker. All of the kind of housekeeping, all the messages are being handled by Bookkeeper. That's Bookkeeper's strength, is to handle that. So it delegates the work over to Bookkeeper to do it. And then there's also Zookeeper. It's also an Apache project that helps to manage cluster, like metadata, coordination of tasks between different Pulsar clusters and things like that too. So that's what Pulsar components are. Okay, so this one, I may not be spending as much time, but I already talked about the primary challenge in this kind of cloud environment is to deal with the scaling part. There's partition rebalancing when you need to grow your systems, grow all your clusters, your nodes. It just knows automatically how to rebalance. That's a really, really big thing, because from what I heard is that doing Kafka, you have to do things, you have to have a separate team to deal with. How do you deal with growing and shrinking is a large part of the work itself. So it really reduced the cost, overall cost too, if you choose a platform like Pulsar. Okay, and then this is that, and I won't go too much, but I think I only have like 1 minute or something. So I'm just going to quickly kind of tell you about some key differentiator, the benefits of using Pulsar, and for example, like it running in Astro streaming. Basically, we separate out the compute and the storage. As I mentioned, storage is being handled by Bookkeeper. So Pulsar can worry about dealing with all the messages flowing through. And they have separation of concern. So it makes the growing scalability aspect of your ecosystem much better too, easier to manage. And then also the geo-replication is also another strength, that if you have a big companies in data center in different parts of the world, the geo-replication is a big strength to it, because you can have different, for example, data compliancy that happens in different regions, and you can set different rules, and they can be handled accordingly, that without you worrying so much. That the infrastructure is already there to support it, essentially. And then multi-tenancy, essentially, too, in your cluster, you can divide up into different kind of aspects of concern for your company. Like a finance department has its own tenant, and marketing has its own. So it helps you to manage all your data, the flow of messages much more better in this case. And then another thing also is about the message processing model too. You can have an exclusive subscription in which you can turn Pulsar into like a message queuing rather than using the traditional pub-sub type of mechanism, a dedicated receiving consumer, or failover kind of processing mode or shared mode in a cloud-native environment. Many consumers, receivers can share the same subscription. Or if you want the messages to guarantee it to come in order, to be, when it's published, you want to receive on the other side in order, you can use a key share mode too. So those are some of the advantages. So, okay, so this I won't go through, but I want to also point out a couple more kind of highlights of these developer features. I want to explain, right, data pipeline too is essentially you can use a system like messaging like this to build your data pipeline. Think of your source of data decoupled from your end, and you go through the middle process is what Pulsar can help you to do, to transport and to transform accordingly. So it's very efficient. You can write to what is called a sink. The sink is where you transform all your data, you write it to the destination. Think of it that way. It's like Lego pieces, right? You can plug that in and easily plug it out. You can chain it together, different pipelines chained together that flows through your entire ecosystem. So that's the thing about data pipeline. And then let me go here. So Pulsar functions, again, helps you. I already talked about function as a service. It functions much like AWS Lambda, Google Function, Azure kind of serverless function. And then there's also this feature called Pulsar schema, because you have to deal with data. Every time you want to send data over, if you're a developer, you're aware you need to serialize your data, flatten your data structure, goes through the wire. On the other receiving side, you need to deserialize it, right? So we have Pulsar schema that helps you with that too. So I want to highlight that. Then there's also this data pipeline. The model here is using a source and then go through Pulsar, transform it, and a sink. The sink, too, can be MariaDB. We're talking about MariaDB can be a sink. There's also Elasticsearch. It's already pre-built as a sink. Kafka, we recently released Astro Streaming. We have Kafka Sync. Or we also have, RabbitMQ Sync, right, for example. Now, many sinks. Now, if you want your own sync, specialized sync, you can write your own sync using Pulsar IO, this feature, too. It's essentially an SDK that you can build your own sync as well. So it's very flexible. All right, DataStax flavors. Just want to real quickly. Astro Streaming, Luna Streaming, and open source. So this I know there's just so much information. So, but I wanted to say Astro Streaming is what you can try it out. And then Luna Streaming, essentially Astro Streaming is using our managed cloud. Everything managed for you. But Luna Streaming is you run it on your own cloud system, but you can purchase our support too. But Astro Streaming, we're giving out $25 credit every month for you to try it out without you even giving your credit card. So, okay, so I won't kind of talk about these now, but I won't have time to do this, but I wanted to quickly show you resources is here. I will share with you the screen, my slide deck. AstroDB, there's also a special code. If you want to get more, $200 in credit, you can use an open source code and use this special link, just so you know. And also, please check out our 5 Minutes About Pulsar series on YouTube, on our YouTube channel. And again, we have different subtopics about Pulsar that you can learn about, that our product team, engineering team, we all chip together to do some small bite-sized teaching for you. So if you're falling asleep, you need something. No, I'm just kidding. You can watch one of these 5 minutes and you fall asleep. No, I'm just kidding. But they are meant to be short and sweet. Okay, I also have a Twitch stream that I do every Wednesday afternoon. If you want to follow a bit more in-depth, I go into developing the producer, the consumer, all these developer details. And then join us at the Hood. We have a Pulsar neighborhood meetup group and also a wiki page you can contribute. And then with that, thank you very much. And I think I go over a little bit. Thank you. Okay, thank you.
Thank you.
Thank you.
Thank you, Mary.
Thank you, Mike. Okay.
Maybe we've got time for one question while we set up the next speaker.
Sure.
So if anyone has a question.
Thank you. Is that what you asked? Almost did not, but thank you. Yeah, like I said, if you come to my Twitch stream, I have a lot more to show you. And you can join my Twitch stream too if you like. Yeah, I invite viewers to come and join me because sometimes it's fun too. You talk about things and you share with people. And Twitch is so casual, right? There's no kind of fancy requirements. Okay. So anyway, thank you.
Thank you very much.